In this session, I'm going to prove the constant rule. The constant rule says that the derivative with respect to x of some constant c equals 0. And so, if we let f of x equals some constant c, then the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x, this is the difference quotient, is simply equal to the limit as delta x approaches 0 of c minus c over delta x. Now the reason for this strange looking turnaround is easily represented geometrically. If we take a look, let's draw a Cartesian grid here. So let's draw some vertical line here. There's our y-axis, and then we'll draw an x-axis. Let's take some line. Let's make it this. Oops. How about if we just draw the line, and then we'll change the colors. Now, if we take a look at this line from the standpoint of this being, let's say this is y equals 3. This is simply a horizontal line. We know that the derivative is a representation of slope. What is the slope of a horizontal line? The slope of a horizontal line is 0. And so naturally, we would expect the derivative of some constant to be 0. But in this case, f of x is this same constant value, 3, and f of x plus delta x, no matter where we go on the x-axis, it's always going to be that same constant, in this case 3. Here, symbolically, we've represented our constant as c. So f of x is always going to be c no matter where we are on the x-axis, no matter which interval we're in. So f of x plus delta x is c, and f of x is c. So back to it here, we can see that the limit as delta x approaches 0 of 0 over delta x. We never get to the chance where we're actually taking the limit, because 0 divided by anything is simply 0. And so there we have it. The derivative with respect to x of any constant c equals 0.